Ziua. O să facem lucrurile astronomic, right in time, 10 a.m., astronomical local time, civilian local time. Welcome, everybody. Welcome to this forum organized, and I am very, very pleased to welcome people, astronomers, academicians, professors, enthusiasts in astronomy, amateurs, students. So, I have a short comment before starting. So, Your Excellency, Mr. Vice President, Mr. General Secretary, our special guest, Monica Rubio, ladies and gentlemen, our forum is entitled Challenges of Contemporary Astronomy, Contemporary Astronomy in Society and Chilean Experience. This astronomical forum is organized by the Astronomical Institute of the Romanian Academy and the Embassy of Republic of Chile in Romania. It aims to be a landmark event dedicated to astronomy, enthusiasts, researchers, educators, and everyone interested in mysteries of universe. Astronomy is a fundamental science, the first exact science that emerged from the philosophy in antiquity. Its objective is the study of celestial bodies, both in terms of their dynamics and their physical properties, as well as the formation and evolution of the universe. The Forum has the privilege of hosting world-renowned astronomers, professors, and researchers with significant influence in national and global scientific policy and decision-making, diplomats, cosmonauts, and future astronauts, professors, enthusiasts, pupils, and students. Thank you for the presence, and also thank to the Presidium of Romanian Academy for the presence and facilitating this organization for the forum in the magnificent aula of the Romanian Academy. The forum's guest of honor is the astronomer Professor Dr. Monica Rubio, Vice President of the International Astronomical Union, a prominent figure in astrophysics, internationally recognized for the essential contribution to the study of star formation and the interstellar medium. To my humble knowledge, this is the first time in the last 50 years that astronomy in Romania benefits from the presence of an IAU representative at this level. I thank Monica Rubio on behalf of Romanian astronomers. The program will cover approximately 3 hours, and in the last part, this forum will take place in an informal way in adjacent hall for networking and discussion and discussions with the press. To begin, I give the floor to the representative of Presidium of Romanian Academy, academician Nicolae Zamfir. Professors, you have the floor.
Your Excellency, Ambassador Bravo, Professor Monica Rubio, distinguished colleagues, honored guests, dear participants. I'm very honored and glad to welcome you on behalf of the Romanian Academy leadership as this forum dedicated to one of the most profound and forward-looking scientific fields, astronomy. The theme of this forum, the challenges of contemporary astronomy in society and the Chilean experience, resonates strongly with the mission of our Academy, to promote scientific excellence while encouraging international cooperation and meaningful dialogue between research and society. The organizers, the Institute of Astronomy, a prestigious pillar of the Academy, continue a tradition of excellence in astrophysics and astronomical research. In an age marked by the accelerated expansion of scientific frontier and global cooperation in space sciences, the contribution of Romanian researchers remain not only relevant but important. This forum stands as a testament to the vitality of the Romanian astronomical research and its openness to international dialogue, interdisciplinary exploration, and scientific innovation. The challenges we face today, from understanding the origins of the universe to developing technologies for space exploration, require precisely the kind of thoughtful engagement and rigorous inquiry that Forum promotes. Astronomy today is not only fundamental science that probes the origins and structure of the universe, it's also a source of technological advancement, educational inspiration, philosophical reflections. As we move into an era of data-driven discovery and global scientific cooperation, astronomy becomes a bridge between disciplines, countries, and continents, as this forum proves. The Chilean experience stands as a remarkable example of how a country can strategically position itself as a global leader in a scientific field, namely in observational astronomy. With some of the world's most advanced telescopes hosted in the Atacama Desert, Chile demonstrates how natural geography, sustained investment, and international collaboration can together elevate both science and national prestige. In this context, Romania is proud to contribute to the international astronomical community through the work of its own researchers and institutions, foremost among them the Institute of Astronomy of the Romanian Academy. Through such forums, we strengthen scientific partnership, learn from exemplary models like Chile's, and reflect on how astronomy can enrich education, technology, and public understanding. The Romanian Academy reiterates its unwavering support for fundamental research and its belief in the value of astronomy as a field that connects us to the larger cosmos while strengthening our scientific culture and educational mission here on Earth. The Romanian Academy expresses its gratitude to the organizers and participants of this event and reaffirms its commitment to supporting fundamental research, international collaborations, and the integration of science into the broader fabric of society. We congratulate the organizers, speakers, and participants for their commitment to advancing astronomical knowledge and for fostering collaborations across borders and disciplines. May this gathering inspire new ideas, partnerships, and discoveries. We wish this forum fruitful discussion, inspiring exchange, and lasting connections. Thank you very much.
Thank you, Mr. Zamfir. This forum was made possible by the initiative and the idea of His Excellency, Mr. Giulio Bravo, and the team of the Embassy of the Republic of Chile in Bucharest. A friendly thoughts to Mrs. Daniela Gane and Raluca, and their logistical support. Please, Mr. Ambassador, you have the floor.
Mulțumesc, Mirel. Bună dimineața. Good morning. I'm really happy to be here, and I'm happy that we were able to organize this forum. For us, it was very important to have this kind of activity, to put together academic, scientific research, and to look for new ways to celebrate the 100 years of our bilateral relation between Chile and Romania. So I would like to thank the Romanian Institute, and also the Romanian Academy, and also the Romanian Institute and Mirel for taking and accepting the invitation that we did to celebrate the 100 years of diplomatic relation between Chile and Romania. I think that this activity dedicated to scientific collaboration between our two countries, with a special attention to astronomical research, will mark a new beginning in our relation. I also would like to thank the speakers, and especially Professor Mónica Rubio, for accepting this invitation. And to all of you, especially the students that are with us today, to be here and to attend this ceremony. 100 years ago, Chile established its residence embassy in Bucharest. This was on the 5th of February, 1925, a date that marks the formal beginning of fruitful and solid bilateral relations between our two countries. Chile recognized Romania independence on the 16th of November of 1880. Since then, my country has remained faithful to the commitment assumed by then President of the Republic, Mr. Aníbal Pinto, when he, and I quote, gladly accepted the offer of friendship of His Royal Highness King Charles I, and corresponded to the desire to, and I quote again, establish good and cordial relations between Chile and Romania. These relations are based on the coincidence of values and principles shared by both countries, such as respect of rule of law, the promotion of defense of human rights, the sovereignty and territorial integrity, as well as the peaceful settlement of dispute, compliance with treaties, and respect of the international law, among others. An important aspect that I would like to highlight during this period has been the humanitarian work carried out by our resident embassies. An example of this is the protection provided by Chilean diplomats, such as Samuel del Campo, to those persecuted by Nazi Germany during World War II in Romania, as well as assistance provided by the Romanian Embassy in Santiago to the Chilean citizens after the 1973 coup d'etat. Recently, we hosted President Klaus Iohannis in Chile in April 2023, and Romania invited the Foreign Minister of Foreign Affairs, Alberto Van Claven, in August that year. This high-level visit confirmed the strength of the ties that unites both countries. Today, we want to go further. We want to deepen these ties through knowledge, science, research, and education. The activity that we are carrying out seeks to open a path to allow us to generate exchange of researchers and students between our countries. We want to highlight an area where Chile took advantage of a natural laboratory for the investigation of the secrets of the universe, like astronomy, And we have circulated, and if you don't have this paper, I would like you to collect the fact sheet of what is astronomy in Chile. Today, Chile hosts more than 40% of the world's astronomical observation and is home to some of the largest and most advanced telescopes, including the ALMA radio telescope, Las Campanas telescope, and the Paranal telescope. But also the Giant Magellan, the Extreme Large, and the Vera Rubin telescope under construction will position my country as the astronomy capital of the world. By 2030, Chile will concentrate more than 60% of the terrestrial astronomical infrastructure with an investment of more than $6 billion. The large volume of data generated positions my country as a great big data laboratory for astronomy. But all of this is a result of a state policy that dates back to the 1960s, with the enactment of a law in March 1963 that empowers Universidad de Chile, where Professor Rubio works, to sign cooperation agreements with international scientific entities, and also by a milestone agreement that was signed in November of 1963 for the installation of the European Organization for Astronomical Research in the Southern Hemisphere, ESO. According to this policy, all observatories installed or to be installed in the country must assign 10% of the observing time to Chilean astronomers and academic institutions. With this, my country has access to the most advanced scientific instrumentation. This has allowed the development of a community of astronomers and astrophysicists, as well as 24 research and training centers in Chilean universities. But astronomy is now facing some dangers. You know that we have the mega constellation in the space. So astronomy requires a clear, undisturbed environment. The night skies are a valuable and unique natural resource that require concerted effort for their protection. We, Chile, the Foreign Ministry, we have been a very active promoter in the maintenance and preservation of dark and silent and quiet skies in the Multilateral Forum, especially in the United Nations Committee on the Peaceful Use of Outer Space, COPUOS. And I'm very grateful to have here the participation of Ms. Ulpia Botesano, the chair of the Scientific and Technical Subcommittee at COPUOS. And Ulpia, we are going to continue working and with our effort to seek solutions to mitigate the negative impact of mega constellations that are affecting the observation from the Earth. And I thank you for your efforts and your collaboration. We were able to install this topic in the agenda of COPUOS, so thank you so much for all your efforts. So collaborations allows us to achieve remarkable advances in science and technology. Mirel and the professor Nikolai has also raised that this is a collaborative effort, international collaboration. And that is what we need to continue working. And I want to send the message that we need, and we are going to strengthen our, to work in cooperation between Chile and Romania, to have scientists that can continue contributing to the development of scientific research and the exploration of the universe from my country. I'm completely convinced that this would open a new paradigm to our centenary bilateral relation. Thank you all of you for your presence here. Thank you to the speakers, Mirel, for all your efforts and to be able to take our invitation and to make this possible. Thank you, Mr. President, also for hosting us today. Thank you so much. Molto much.
Thank you, Mr. Bravo. Our program will will suffer because we need to change, we need to switch a little bit in the program. Mr. Daniel David, Minister of Education and Research, is not able to attend our meeting, and Mr. Andrei Alexandru, the President of the National Authority for Research, will be late at 10:20. We are waiting for his intervention. I will give the floor now to Ulpia Botezatu, Dr. Ulpia Botezatu, Chairperson of the Scientific and Technical Subcommittee of the United Nations Committee for Peaceful Uses of Outer Space. Ulpia, you have the floor.
Good morning. Good morning, Your Excellencies, distinguished Dr. Monica Rubio, honorable members of the Romanian Academy, distinguished guests, friends, ladies and gentlemen. It is an honor to address you today in this prestigious aula of the Romanian Academy and to share with you the contribution that Romania brings to the international community through its leadership of the Scientific and Technical Subcommittee of the UN Committee on the Peaceful Uses of Outer Space for the period 2024 to 2026. As the chair of this subcommittee, and in my parallel role as a co-chair of the action team on lunar activities consultation, I am privileged to represent Romania in one of the most dynamic and future-oriented diplomatic arenas of our time. I'd like to express my sincere gratitude to the Romanian institutions responsible for our national space efforts, as well as to the member states of the committee, including the Republic of Chile, for placing their trust in me to lead this subcommittee. I reaffirm my full commitment to advancing our shared work in a spirit of transparency, inclusiveness, and scientific cooperation. During my chairship of the Scientific and Technical Subcommittee, I had the privilege of presiding over nearly 40 formal sessions that can be rewatched at the links shown on the slide across the 61st and 62nd meetings of the subcommittee, covering a broad range of critical topics from space debris mitigation and nuclear power sources in outer space to planetary defense, space weather, as well as quiet and dark skies. Romania's leadership during this term has underscored the increasing importance of space data, infrastructure, and policy as enablers of sustainable development and international cooperation. The continuous growth in membership, now 104 member states and 56 permanent observers, further confirms the committee's unique position as a global platform for a multilateral dialogue. Distinguished guests, as space activities continue to expand at an unprecedented pace, the protection of astronomical observation conditions has emerged as a critical global concern. The increasing number of satellites, especially large constellations, poses real challenges to the visibility and radio quietness of the night sky, essential elements for ground-based astronomy. In recognition of this, the Scientific and Technical Subcommittee added a dedicated agenda item entitled Dark and Quiet Skies, Astronomy and Large Constellations, Addressing Emerging Issues and Challenges. I wish to acknowledge the outstanding leadership of the Republic of Chile, which, together with the International Astronomical Union, co-chairs also the Group of Friends on Dark and Quiet Skies, their efforts have been instrumental in promoting this issue at multilateral level and in supporting science-based policy solutions. Chile's commitment to the preservation of astronomical heritage, including its stewardship of some of the most important observatory sites, continues to inspire and guide international cooperation in this area. I'd also like to highlight Romania's contribution to this discussion, in particular through the Astronomical Institute of the Romanian Academy, which is actively engaged in expert-level consultation and supports the global call to ensure that the progress in space does not come at the expense of fundamental scientific capabilities on Earth. This agenda item goes beyond technical parameters. It touches upon intergenerational responsibility, scientific integrity, and the equitable governance of shared orbital environments. It is my strong belief that our continued dialogue on this topic will lead to practical, coordinated, and sustainable solutions for the benefit of science and societies alike. Distinguished guests, another key achievement under Romania's chairship has been the international recognition of planetary defense as a strategic priority in the governance of outer space. With the strong support of member states, and based on a proposal initiated by Romania, the Scientific and Technical Subcommittee recommended and the United Nations General Assembly adopted Resolution 79/86, proclaiming the year 2029 as the International Year of Asteroid Awareness and Planetary Defense. This resolution is rooted in a unique astronomical event. On 13 of April 2029, the asteroid 99942 Apophis will pass extraordinarily close to Earth, closer than many satellites, yet with no threat of impact. It will be visible to the naked eye in various parts of the world, make it a once-in-a-lifetime opportunity to engage the global public. The year 2029 will provide an exceptional platform for education, cooperation, coordinated preparedness, bringing together governments, scientists, educators, and civil society under our one shared objective, raising awareness and strengthening planetary protection efforts. The initiative is now featured on the UN official observances calendar, marking that important moment in how the international community approaches near-Earth objects risks. Moreover, this global campaign builds upon the collaborative work carried out under the auspices of two key multilateral mechanisms supported by the subcommittee: the International Asteroid Warning Network, I1, responsible for detection and information sharing, and the Space Mission Planning Advisory Group, which provides expert coordination on possible mitigation missions. Both bodies exemplify how international cooperation can turn scientific vigilance into actionable policy, helping to ensure that planetary defense becomes a cornerstone of long-term space sustainability. Distinguished guests, I'm also pleased to highlight another important initiative developed under the auspices of the subcommittee, the establishment of the Action Team on Lunar Activities Consultation, or ATLAC. This expert platform was created to develop recommendations that support improved international consultations on lunar activities with a focus on transparency, peaceful uses, scientific cooperation, and potential benefit sharing. I am deeply honored, excuse me, I am deeply honored by the trust placed in me and in my co-chair, Mr. Hassan Abbas of Pakistan, to lead this effort on behalf of the committee for the 2025 to 2028 period. Our work has already begun with the structured intersessional consultations, but also formal and informal meetings held in Vienna and remotely, bringing together inputs from member states and permanent observers on potential priority topics and governance approaches to consultations on lunar activities. ATLAC reflects the growing awareness that lunar exploration is no longer a distant ambition, but an evolving reality, one that requires responsible, inclusive, and forward-looking policy and dialogue. I look forward to continuing this work in a collaborative spirit, and I thank all delegations and institutions from domestic institutions and from above that support us and contribute actively to shaping this initiative. Ladies and gentlemen, we are entrusted with a meaningful and forward-looking responsibility to advance international cooperation on safety, security, and sustainability of outer space for the benefit of all humankind and for future generations. In my capacity as the chair of the Scientific and Technical Subcommittee, I remain confident that our collective efforts, grounded in science, diplomacy, and supported by the institutions like the Romanian Academy, will continue to yield tangible and lasting results. I look forward to continue this important work together in a spirit of constructive dialogue and shared purpose. Thank you.
Thank you very much, Ulbia. Now I have a huge pleasure to give the floor to our cosmonaut, astronaut, Dorin Prunariu. Dorin, please, enchanting us.
Your Excellencies, ladies and gentlemen, actually on the screen my presentation will be in Romanian and I will make the presentation in English. As long as I have an outer space experience, I just want from the very beginning inform you that exactly today there are 44 years from my landing from the outer space on board of Soyuz 40 spacecraft. The cosmic flight changed my vision of the world, of cosmic phenomena, and in this context, astronomy plays a vital role in multidisciplinary science research and in forming a correct view of our cosmic existence. Just a moment. Okay. The astronomy offers a unique perspective on the existence. It offers to the astronauts and to any other people an integrated vision. Earth, seen from space, offers a holistic perspective. Borders are disappearing. The atmosphere seems fragile. The position in the solar systems, seen from the outer space, it's a little bit different. We understand our planet's place among the celestial bodies, and gravitational relationships became obvious. A personal transformation occurs into the outer space. Astronauts report a profound shift in consciousness. The spatial existence redefines perception of reality. Up there, you have great loneliness, and of course, besides the cosmic perspective. The space has a psychological effect on astronauts. Seeing the Earth as a single fragile organism causes a profound inner transformation. The fragility of life, also, it's another problem touch up there. The blue ball seems incredibly vulnerable in the cold vastness of outer space. Political divisions disappear completely in the face of the overwhelming cosmic perspective. So, transcending borders, it's another effect of the outer space. Astronomy becomes the natural link between rigorous science and existential philosophy. So, a philosophical bridge just is built up there into the outer space for the people flying up there. The personal impact of cosmic observations offered me a profound transformation. Consciousness and perception of life change irreversibly. The overview effect fundamentally changes the perspective on the Earth and humanity. The cosmic connection, you feel directly that you are an integral part of the vast universe. And also you redefine some concepts, home and horizon, take on a completely new and profound dimension. The multidisciplinary research in astronomy, I was also in a way connected during my training for the spaceflight. It offers the possibility to connect with history and social sciences. The study of the evolution of civilizations through the prism of ancestral astronomical observations is very important. Look, by instance, the calendars and orientation developed from the very early times of our civilization. The connection with fundamental physics, it's also very important. Relativity and quantum mechanics meet in astronomy. Cosmic phenomena validate theories. Application of astronomy in earth sciences, geology, meteorology, and environmental sciences benefit from space observations, monitoring of planetary changes. So the important tools and discoveries connected with the astronomy refers to radio telescopes. It studies gravitational phenomena invisible to the human eye, detects cosmic microwave background radiation, spectroscopy, it's another important discovery. It analyzes the composition of stars through the light emitted. It provides information about nuclear fusion processes. Space telescopes, James Webb, Hubble, COBE, the Cosmic Background Explorer, have revolutionized the understanding of the expansion of the universe. Observations up there into the outer space are not affected by the atmosphere. X-ray astronomy, another important discovery connected with the astronomy. It allows the observation of extreme phenomena. It studies gravitational collapse and matters under extreme conditions. Astronomical techniques and instruments in space offer us a superior clarity, about 100 times more times clearer we see the universe than from the ground. Also, it offers a full spectrum of the waves we register from the outer space, comparing with the Earth, where all the images pass through the atmosphere and are filtered. Incredible precision of astronomical measurements from the outer space. It's an incredible precision. You have digits there. And also from the outer space, you are not limited by the rotation of the Earth or seeing just a part of the sky. Up there, you can see 24 hours, 7 days per week, the universe. Uninterrupted weather interferences also. Okay. Referring to the fundamental theoretical models, we analyze the cosmic inflation. It's an exponential expansion in the first moments of the formation of the universe. We study the general relativity, explanation of the curvature of space-time. We study dark matter and dark energy. It's a, for now, mysterious component of the universe. And of course, we studied from the very beginning the Big Bang theory and the origin of our universe. Astronomy in the knowledge of the universe. We, of course, are very much connected with the help of the astronomy to the star formation. We study of nebula and condensation processes of matter. We study the evolution of galaxies, understanding the structure and distribution of matter on a cosmic scale. We study the exoplanets, who are very interesting if life exists somewhere else in the universe. and we start from far, the exoplanets, the search for other worlds and the potential for life. Gravitational waves, detecting disturbances in the fabric of space-time. Of course, practical application of astronomy refers to derivative technologies. Space research has generated numerous innovations, advanced materials, sensors, and purification systems. Refers also to navigation systems. GPS, global positioning systems, and satellite communications revolutionized everyday life. Modern technological infrastructure depends on these systems. And of course, from practical point of view, it's the planetary monitoring. The satellites track climate change and natural disasters. Astronomical observations help protect the planet. Astronomy in education. It's a very important topic. We don't apply as necessary. So in education, astronomy develops observation, develop systematic observation skills on children, develops the curiosity, stimulating interest in natural phenomena, develops critical thinking, training, analysis, and synthesis skills, and also develop scientific method, learning to formulate and test hypotheses. The necessity of astronomy in schools, as I said, it's very important. Even if we don't teach astronomy in the schools, there are a lot of champions in astronomy from our children, and not only in our country. It develops the early curiosity. Children naturally ask about stars and planets. Astronomy capitalizes on this innate curiosity. The formal education, using astronomy in the schools, integrating astronomy into the curriculum, develops scientific thinking. Practical observations reinforce theoretical concepts. The access to observations is very important also. National observatories offers unique educational experiences. ALT, as said, extract, load, transform, especially in big databases, opens up new horizons for research. Also, astronomy is very important in combating pseudoscience. You all heard the new so-named theory of the flat Earth. Of course, astronomical observation clearly demonstrate the spherical shape of the Earth. Eclipses and global navigations confirm it. Astronomy versus astrology. Also, most of the people with very low knowledge of astronomy, they confund sometimes astrology and astronomy. The differences between unfounded predictions and the science of celestial positions, it's very important. Constellations are apparent grouping, not influencing. Conspiracy theories versus evidence. Ancient aliens contradict the archaeological evidence. Scientific methods explain human achievements. A few words about the future of astronomy and space explorations. So, trips to Mars and beyond are the next natural steps in the exploration. Propulsion and life support technologies are evolving rapidly. It offers us a view on interplanetary missions. The new generation of space observatories will directly study the atmosphere of exoplanets. The search for biosignatures is becoming the main direction of research with advanced telescopes. Gravitational wave detectors open a whole new window to the universe. We will hear about collision of the stars, neutronic stars, and black holes. So, gravitational astronomy is developing. Also, astronomy offers a field for global collaboration. The progress of astronomy requires international efforts and an unprecedented scale. Space becomes the terrain of a global scientific cooperation. Astronomy, it's a bridge between Earth and the cosmos. Speaking about the importance of astronomy, fundamental to the future and survival of humanity as a stellar species. Speaking about exploration and understanding, knowing the cosmos will allow us to go beyond our planetary limits. We are messengers between worlds, barriers of the unique cosmic experience. And, of course, the sky has no longer limits for those who dare to look beyond. Some conclusions? Of course, astronomy helps us understand our place in the universe. It provides essential insights into human existence. Also, astronomical research propels technological development. Space discoveries inspire terrestrial innovations. Knowledge of the cosmos, it's an investment in the progress of humanity, inspire future generations of explorers. And of course, thinking about critical educations, astronomy helps combating myths, requires solid scientific literacy. Astronomy develops rational thinking. And thank you for your attention.
Thank you, Doreen. Our special guest is Dr. Monica Rubio. So I spy a little bit your curriculum vitae, dear Monica. Dr. Monica Rubio defended the PhD thesis in Université de Paris, France, and I had the pleasure to meet and to speak with the supervisor Jean-Luc. The subject was related to the Magellan molecular clouds. Monica Rubio is full professor at the Astronomy Department of Universidad de Chile. She served as director of astronomy program between 2008-2014, and she served also as vice president of the National Commission for Science and Technology, CONICET. In 2019, president of the Chilean Society of Astronomy, 2019-2020, and vice president of the Division H, Galaxies, of the International Astronomical Union between 2018-2020, and now vice president of the International Astronomical Union. Monica, you have the floor. It will be an extended presentation, please.
Good morning. It is really a big pleasure, and I'm very happy to be here in Romania and in this wonderful place of the Academy of Science. So thank you very much to the organizers, the Chilean Embassy and the Academy of Science, to be able to be here and share with you some of the work I have been doing as an astronomer, and also invite you and, of course, students and young researchers to continue to do astronomy. So, this is astronomy, the origins. From where do we come? From where do we go? What is the origin of life? How did the universe, the stars, the planets originated? Those are the questions that humankind has been asking for many years, and the stars and the skies have been a company to humankind since humans are in the earth. And I'm sure that all of you have been able to watch a wonderful night sky in a dark site in any country. That's what I was amazed when I was, I had, say, 14 years. I was at the high school. And I look at the sky and I say, oh, what are all those little points that are there? They are twinkling. They are the stars, they told me. And how were they formed? How did they get there? So that were the questions that I had, that I decided, okay, I'm going to try to understand what are these objects that I see in the naked eye. So my first research and what I have been doing during my life as a scientist and astronomer is to ask myself how the stars were born. We knew that the stars lived and that the stars died. So, in our experience, everything that lives and dies has to be born. There's a cycle. But we didn't know until very recently where and how the stars were born and why. We had so many decades and centuries of astronomy, and we didn't know yet how stars were born, something that we saw every night looking at the sky. And why was that? Do you see anything on the screen? You don't see anything. It's dark. It's invisible to our eyes. And today, we know that stars are born in regions which we are not able to see. And that is why the reason that it took us so long to understand where the process and where the stars were born. We cannot see with our telescope, with our visual telescope, optical telescope, where this happened. And science is based on the physics of nature. And the physics of nature told us is that what you needed to form a star was to have a cloud of gas that, because of gravity, it will start to contract, and somehow during that process you will make a star. Also, we know our star, the sun, is not alone. It has a planetary system around. So the physics said that we had to form a central object and also some planets around. That's what we knew from physics. But could we prove that this was happening in the universe? How could we measure that? Well, again, physics is the answer. We know that when a cloud of gas is compressed because of the gravity and contracts, the temperature of the gas cloud is increased. So we needed to find objects that show temperature. And how do we measure temperature in the universe? Well, here on Earth it's very easy. We put a thermometer and we measure the temperature. But how we do that on objects which are far away? We cannot do that. So, but we knew since many centuries already that any object that had a temperature would emit radiation in what is called the thermal radiation, something that after COVID, we are very well known how to measure that temperature with a small apparatus that will measure your temperature, your body temperature, without putting something on yourself, just from far away. And that we knew also from infrared night detectors, that if we looked through them, we would be able to see during the night when it was completely dark. So this was the answer. What we needed was to have the instruments that were able to detect objects in the skies that showed temperature, but they were invisible. And unfortunately, this kind of radiation, which is part of a family of radiation, which is the electromagnetic spectrum, we knew about the electromagnetic spectrum. And this was a similar kind of wave as the visual, the optical spectrum. So we knew the physics of this emission. And we also knew that in this family, we had some other kind of emission that we just heard: gamma rays, X-rays, ultraviolet, and radio waves. So the universe could emit and produce the processes in the universe, all this wide range of electromagnetic emission. So what we do, the astronomers? Well, we convince and we ask our engineers and the technicians to develop the instrumentation that we need in order to detect those radiations. And as we saw, well, many of those radiations, we cannot have it from ground-based. You need space observatories to detect those emissions because our atmosphere impedes that these radiations come to ground. For the optical, it was very easy, and that's how astronomy developed. For radio astronomy after World War II, it was a big development because of many receivers and antennas were developed during World War II. And after the war, well, they pointed to the sky, and radio astronomy started. But we also had to go outside, and we now have Hubble, Webb, and even a stratospheric plane that flies very high to detect the infrared waves. So now we know that stars are incubated in these dense clouds, which are dark and also have gas and dust, and that the dust in these clouds absorb the light. So we need these other techniques and this other instrumentation in order to explore and make the research on where the stars are formed. So we need telescope, infrared telescope, and radio telescope that we say they see the invisible. Those are some of the ones that I have been using. I was able to fly on SOFIA, a stratospheric NASA airplane, and also using one of the infrared telescopes on space, Herschel telescope, and radio telescope located in Chile, like the Apex radio telescope. So that's what we had: the instrumentation, we had the physics behind how would stars form. We knew that in skies there were these dark patches that were very well known and described and even cataloged by astronomers in the 1950s. And okay, so let's take a look on these other wavelengths to see if really the model or the physics was there. And if we go into the infrared on the same region, we see that it's not dark anymore, and we see many objects. So there are objects seen on the infrared which have temperature inside these dark clouds, and you see that these objects are like stars. A very well-known area in the Orion Nebula, in the Orion constellation, that has been named as the cradle of stars, we see on the left-hand side that is completely dark. When we look into the infrared, it becomes full of stars, and all these stars are baby stars, are stars which are in the beginning of their life, but are still inside these very dark clouds. The most wonderful, in my view, image of what a dark, dense clouds in space is in our galaxy is the pillars of creation. 3 very, very dense and dark columns of gas and dust that were imaged by the Hubble Space Telescopes. So if we look into the infrared, the same areas, well, we see that now all the dust disappears and we start to see the stars inside that. And even with the Hubble, the Webb telescope, we can see a wonderful image of all this dark gas. And if you look very closely into the top of each of the different pillars, you will see a little stars in each of them. So that's the region where our stars are being born, and all the process is taking place. So these are the regions where stars are formed: dark gases of cloud. But we want to know also what is this gas made of? It's dark, but what is the composition of this gas? Okay, so the first answer is said, okay, let's see, what is the universe made of? And we know that most of the universe is made of the most simple atom, which is hydrogen. And is there any hydrogen in there? Well, we needed to contract these gas clouds, and on the contraction, in order to form a star, and these clouds are very cold, well, physics told us that the atoms, the hydrogen atoms, could become coupled and make a molecule of 2 hydrogen atoms. Great. What is the emission of a molecule of a hydrogen molecule? There's no emission from hydrogen molecule. We knew in the universe that after the Big Bang, there was a process that transformed the energy of the Big Bang into particles, into atoms. And the only atoms that were made were the hydrogen, helium, the second atomic number, and a little bit of lithium and the deuterium. But all the other atomic elements, which we call the astronomers metals in astrophysics, with atomic number larger than 4, had to be made in the center of a star. So we need a star to form all the elements that we know in nature. But on the other hand, with the hydrogen that could form the stars, we couldn't see it. We couldn't have the emission from those. And one of the things that we would like to do in the very near future is trying, with the new telescopes that are being built, to find out and to be able to image the first stars. Because the universe, before the first stars were born, it was dark. There was no light in the universe. The stars are the ones that produce the light. So we need to form the very first stars in order to have light in the universe. And this is a periodic table that the astronomers use, because as the stars are born, we know that in the process of creating energy by nuclear fusion on their centers, they create as well all the rest of the atoms of greater than atomic number 4, and different processes create the rest of the atoms. And there were 2 which are very important, which is carbon and oxygen. So in these regions where stars were born, we thought, okay, maybe these regions are already contaminated with carbon and oxygen, and what happens if the 2 atoms join and form a molecule of carbon monoxide? And the atomic physics and the molecular physics says, oh yes, it can be, it is possible, and there will be an emission on the millimeter wave regime, 2.6 millimeter or 150 gigahertz. So we now need instrumentation that can detect that molecule. And this molecule rotates and produces emission at this frequency. Well, this is not a very nice picture. This same molecule, carbon monoxide, is one of the main components of smog. And unfortunately, in Santiago during wintertime, the smog is present in a very heavy way. But because we have smog in the universe, we are now able to study where and how the stars are born. This is the tracer to do the studies of how stars are born. And to convince you that is so, here's a very nice picture of what is called the Horseshoe Nebula, a very dark nebula. And when you observe it on the millimeter waves and CO emission, it's just the same. It's all full of molecular of carbon monoxide. So by studying and detecting carbon monoxide with radio telescope, we can find the properties of these gas clouds. And this is me, because I'm an observational astronomer, and I like to go to the observatories in Chile at Apex or using the big radio telescope in Alma, and also with my students, finding out and doing the research. We have fun, the astronomers. Really, we really enjoy what we do as a... And my main area of research has been two galaxies, which can only be seen from the southern skies, which are the Magellanic Clouds. They are the nearest to our galaxies, and they are satellites of our galaxy, and you can see them naked eye from Chile. So I invite you, all of you, to come and watch naked eye these two very beautiful galaxies. And I started to study these galaxies because on these galaxies, the amount of carbon and an amount of oxygen was different than the one that we had in our galaxy. The Large Magellanic Cloud had only 50% of carbon, and the Small Magellanic Cloud had 20% of carbon. So the ingredients to produce the molecule, the CO molecule that we are able to detect, are very much decreased. And there were other galaxies which had less carbon and less oxygen, and where CO had never been able to be detected. And if we don't detect CO, we cannot study star formation. And then there was this galaxy which only has 13% of the carbon and oxygen to produce the CO molecules, WLM, but it's farther away. It's 10 times farther away than the Magellanic Cloud. So if you apply 1 over distance square, you know that you need a much more sensible instrumentation to detect the emission. And we were able to detect it with APEX, one of the telescopes, on 2013, and this came up as a publication with a group of colleagues from different parts of the world as a Nature publication. And with ALMA, we were able not only to detect the CO molecule in this very low metallicity dwarf cloud, but also to determine the properties of these dense, cold, and dark clouds in this galaxy, and find out where this galaxy is forming stars with only 13% of the carbon and oxygen. So when the universe started, before any star was born, there was no carbon and no oxygen. So how did the process of star formation went through having 100% of carbon and oxygen in our galaxy to 13% in WLM and 0% when the universe starts, before the first stars were born? And this is the area of research that takes my time now. And we are trying to get images and detection of CO emission in galaxies which have less carbon and less oxygen. And shall I tell you? Well, in this galaxy, which is called Sextans A and Leo P, which is ours there, 1 month ago, we received the results of the ALMA observation we produced, and we were able to detect CO emission at that metallicity. So we're writing the paper now. We will be published very recent, but keep it for yourself, okay? So, the stars, the universe, the galaxies. This is what we are studying only with ground-based telescope, radio telescope, space telescope, in order to learn where we live, from where do we come, if we can find life, where did the universe and the stars and the planet originated. And many of the answers to these fundamental questions will come from a site in our planet, which is the northern part of Chile. This is taken from the Hubble Space Telescope, and you can see that there's a region which is always clear. 330 nights of the years are clear, and it's a very stable atmosphere, and that is why all the major international observatories are located in the northern part of our country. And we can see two big areas, the ones near Antofagasta, where Cerro Paranal and ISO and the VLT and the new ELT from ISO is being built, and another group of observatories in the region of La Serena. These are some of the examples of the facilities that are now being operating in Chile. Many radio telescopes that are also devoted to study the very early universe, the cosmic background radiation, and of course the interferometer ALMA. All these are 5,000 meters of altitude. This is an extraordinary place where you can put many, many telescopes, and there's no other place in the world with the conditions, and that is to allow this kind of observation, and that's why we have concentrated all this infrastructure. And as Ambassador was mentioning, Chile has had a policy for more than 60 years to attract and invite international collaborations in astronomy. The next giant telescopes that are being built, we have the extreme large telescope, the European, the 30-meter telescope, the giant Magellan telescope, and the Vera Rubin Observatory. The three of the four are located in Chile. And that is why, and this is a recent image of how ELT is being built. And we hope that by 2027 or 2029, we will have first light on this gigantic telescope. And that is why Chile has become what we call the capital world of astronomy. We have almost 70% of the international infrastructure in our country. And as we heard, the agreement allowed that astronomers working on Chilean institutions have access, 10% of the telescope time access to do the research. So we're now having also a very big news. I would like to invite you, all of you, because the International Astronomical Union General Assembly, which gathers all the astronomers of the world, 86 countries, Romania, one of them, and over 13,000 professional astronomers will meet in Santiago on 2030 to hold the General Assembly of the International Astronomical Union. We expect that in Chile we will have one of the pictures. There's the last General Assembly in Cape Town, South Africa, and where more than 2,000 participants came, and we expect more than 3,000 astronomers to come to Chile. So I would like to invite you, all of you, and also the Romanian Academy of Science and the professional astronomers in Romania, that we start from now on collaborating and looking towards developing scientific collaboration in astronomy in Chile. So thank you very much for your attention.
Thank you, Monica, for this wonderful talk. I don't know if Dr. Andrei Alexandru is coming. I haven't saw him. So the next speaker will be Dr. Magda Stawiński, the former director and emeritus astronomer in the Astronomical Institute, former director and the founder of the Astronomical Institute. Please.
Și asta e un blaster, deci înainte.
N-am nevoie de asta.
Thank you for inviting me to talk. Only 10 minutes for more than 100 years of collaboration between Romania and the International Astronomical Union. So I have to speak about our roots. As everywhere in the world, astronomical concerns have existed in Romanian territory since ancient times. Let us mention just one example, the sanctuary of Sarmisegeduza Regia, the capital of Dacia, dating back from the 2nd century BC. However, when it comes to scientific astronomy, it only began developing after the unification of Moldavia and Wallachia in 1859. More precisely, after the founding of the two universities, the first one was in Iași and the second one in Bucharest. Romania lacked experience in training young people. As a result, they used to be sent abroad for specialization, as is still the case today. Thus, all the first PhDs in mathematical astronomy obtained shortly thereafter came from the most important universities in Europe at the time, La Sorbonne. The first was Spiru Ared, who later became Minister of Education and signed the decree founding the Bucharest Astronomical Observatory, which became the core of the today Astronomic Institute of the Romanian Academy. Interestingly, the same year, in Bessarabia, now Republic of Moldova, which at the time was under Russian occupation, the astronomer Nicolae Donici founded a private observatory on the left bank of Dniester River. In 1918, following Romania's unification, Bessarabia joined Romania again. Donici, who was already widely acclaimed scientist, became an honorary member of the Romanian Academy. On July 28, 1919, the IAU was founded with the aim of regrouping several projects of the time: Cardiciel, Solar Union, Bureau International de l'Heure. It was also a means of bringing together countries that had fought on opposite sides during the World War I. Apparently, it was the political context rather than spirit of scientific cooperation which played a crucial role in the creation of these unions. In this case, the Treaty of Versailles who was signed in end the World War I. In July 1919, scientists already from the allied countries gathered at the Palace of the Academies of Brussels. They decided to create 4 unions, one of them being the Astronomical Union, all under the umbrella of International Research Council. You have seen here, Romania took also part. During the celebration of 75 years since the founding of the IU, I was surprised to find Nicolae Donici on the cover and even the spine on the commemorative book. I managed to get hold many photos and additional information about Romania, thanks to his author, Professor Adrian Blau, former IU president. Shortly after the founding of the IU, during the Romanian Academy meeting in this hall, on October 21, 1921, Stefan Hepites read a letter he had received in Paris from the IU president Bernard Bayot. Hepites concluded the reading by noting that Bayot emphasized Romania's need to join the Union. In 1922, Donici, as honorary member of the Romanian Academy, participated in the first IU General Assembly. Let us recall that Donici has already taken part in the Brussels meeting in 1919. By the end of the first General Assembly, 10 additional nations, including Romania, had joined the Union, bringing the total membership of to 19 countries, 207 members. As May 2024, the Union had just 85 national members and more than 12,000 individual members across 90 countries and territories. Donici was also participating in subsequent IU General Assemblies, in 25 in Cambridge, in UK, then in Leiden, the third one in 28, then in Cambridge, Massachusetts in the United States, and in 35 in Paris. His last attendance was in Dublin, this time only as an honorary member of the Romanian Academy. He had been appelled from the highest scientific forum by the communist leadership in 1948, a decision he never accepted until his death. You can see this commemorative plaque in the Romanian Academy entrance hall. A recent tribute to Donici was given at the 30th IU General Assembly in 2018 in Vienna, where the book Nicolae Donici, a pioneer of the IU, was presented. Donici was also honored at the Romanian Embassy in Paris on February 14, 2020, by IU President Evin van Dijk. Thus, on April 1st, 1990, AIRA was founded, the Astronomic Institute of the Romanian Academy. During the communist period, Romania's participation in IU congresses was virtually non-existent, and by around 90, due to non-payment of dues, the country lost its full member status. This was the most serious breakup from the international scientific community, which severely affected Romanian research. In the early 90s, thanks to persistent efforts with the Romanian Academy and Romanian push for Union Europe, integration and scientific reintegration, we soon regained associate member status and after full membership in the EU. Our research results become increasingly visible through Romanian Astronomical Journal and through international collaborations, particularly thanks to young researchers trained in the world's top universities. Some return to Romania, others stayed abroad, but continue research in their host countries, honoring their homeland. Most remained connected with our institute. A few examples of Romania's presence in IU. In the early 90s, the use of small telescopes became increasingly uncertain. A survey among users revealed they could still serve specialized programs. Thus, in 2000, the IU Division A Working Group on the Future Development of Ground-Based Astrometry was created. It was the first IU working group initiated and led by Romanian astronomers. And in 2004, a special meeting, Astrometry with Small Telescopes, was organized in Bucharest. Another topic of shared interest among astronomers remains education. Since astronomy has disappeared from Romanian school curricula in the early 90s, we launched an international inquiry to seize the global situation. This led to a collaboration with J. Pasakov, then president of the Commission on Education Development and chair of the IAU Working Group on Eclipses. Together, we sent a letter to the education ministers of all IAU member countries. During the next triennium, I served as chair of this commission, the only Romanian astronomer to have chaired an IAU commission to date. Since the name of J. Pasakov mentioned, let us remember IAU events or programs that involved Romania. The most visible and spectacular was the total solar eclipse of August 11, 1999, whose maximum was in Romania, with a central line passing right through the Astronomic Institute of the Romanian Academy. It is a picture taken by J. Pasakov. On this occasion, Romania hosted 2 NATO Advanced Research Workshops and the 24th International School of Young Astronomers. We had some notable guests, included then President Emil Constantinescu, Jean-Paul Zan, President of European Astronomical Society, and Daniel Goldin, the NASA's longest-serving administrator. In the area of education, the NASA program network for astronomy school education has trained teachers for over 15 years in modern astronomy teaching, aligned with AI and other modern techniques. Romania's involvement in the IAU, of course, continues to this day. Both professional and amateur astronomers, whether based in the country or abroad, remain actively engaged in advancing the field. As for the number of collaborative projects between Romanian astronomers and their international peers, a separate presentation will be needed just to list them all. Current status of Romania. It is represented by the Romanian Academy. You have the year of entry, 1922, member status, national member, category first, total active members 35, and it was active represented by National Committee of the Romanian Academy, Romanian Astronomy. We hope to see broader participation in this union from both professional and amateur astronomers, and the Romanian scientists will continue to represent our country successfully. May the union's mission be fulfilled to the highest standard, advancing astronomy in all its dimensions, research, outreach, education, development, through global collaboration. I conclude this presentation, brief as it is, considering the richness of the subject, by highlighting the book, Astronomy in the Romanian Academy, which is dedicated to the 10 astronomers who were both members of the Academy and following its establishment, members of the EU. Thank you for your attention.
Thank you, Dr. Stavinsky. So I am very pleased now to give the floor to Dr. Andrei Alexandru, President of the National Authority of Scientific Research, Doctor of Mathematics, Laureate of Grigore Moisil Award. Mr. President, you have the floor.
Dear Vice President of the Romanian Academy, dear Director, distinguished guests, researchers, members of the academic community, it is a great pleasure and a great honor to be here today to join this esteemed audience representing the National Authority for Research. Well, at the authority, it is our fundamental duty to develop societal views, so it behooves us to routinely take stances and develop long-term views precisely on topics spanning and interconnecting multiple subfields of expertise. As a key institution in the national research and innovation ecosystem, our authority is deeply committed to fostering any and all initiatives leading to the general progress of our economy, safety, health, and human well-being in general. At the authority, we have a double role. First of one, reglementation, and another one, financing. And if we relate to regulation, last year authority, together with the Romanian Academy, rewrote almost the entire legislation of the research, development, and innovation. Now, researchers have a new statute, Law 183 from 2024, which is elaborated with respect to the international practices, with respect of the recommendations of the European Commission via the support mechanism of policy support facility, which is in respect of the regulations in the European Card of Researchers and in the Declaration of Academic Freedom from Bonn. So we have a new law that now is in implementation. We also have another law that stimulates the partnerships, because only by putting together the public research sector and the private entities, we are able to realize the knowledge transfer, to transfer the results from lab to market, and in this way to obtain a sustainable economic growth, stability, and prosperity for all of us. Now we also have financing mechanisms, and in these days we are finalizing the evaluation on the most important research projects competition ever launched in Romania. I talk about the competition of excellence centers with a budget of approximately 1.6 billion euros, that means 320 million euros. 1.6 billion leis, that means 320 million euros. The goal of this competition is actually to deal with societal challenges, to provide concrete solutions of the identified problems of the society, to imply the academic community to solve these concrete problems. And we will operationalize up to 24 such excellence centers in research domains that are connected to the main societal challenges such as digitalization, industry space, one of them, also other research areas. Furthermore, we are able to establish some strategic research domains in Romania that will be financed prioritarily. Some of them are connected to exact sciences. Some of them are also related to space. We have artificial intelligence, quantum technologies, genomics, autonomous systems, also the implications of the physics of lasers, plasma, and radiation. For example, to deal with and to treat cancer, one major application of physics that will be financed prioritarily. We also have financing lines on NRRP and on the cohesion policy. I want to point one major achievement of our authority. Last year, after the entire process of rewriting the legislation, after the adoption of the strategy, of the National Strategy for Smart Specialties, Research and Innovation, and also after adopting the National Plan for Research, Development and Innovation, the European Commission stated that our country fulfilled the favorable condition of well-governance of the strategy for smart specialties of the national and at the regional level. In this way, the European Commission unblocked for Romania more than 8 billion euros via three major cohesion programs: the Program for Smart Growth, Digitalization and Financing Instruments, the 8 regional programs that are managed by the agencies for regional development, and the Program for Health. Only in December 2024 and January 2025, we signed financing contracts of about 500 million euros. a hub for artificial intelligence, a platform of semiconductors, a hub for hydrogen, another project related to nuclear energy, another major project which is called Danubius. So, in this way, a lot of money from abroad, from the European Commission came to Romania and will be used by the research, by the national research and innovation ecosystem in order to assure, as I said before, sustainable economic growth and prosperity. I want to congratulate you in particular. I want to thank you for inviting me here. And as you probably know, I am also a researcher. I belong to the Romanian Academy. I am a mathematician, a logician. So I want to assure you all of my full commitment for supporting the research, either the fundamental research, but also the applicative research and the technological research in order to assure a better life for all of us. Thank you very much.
Thank you, Mr. President. Now, while Professor Daniel David cannot attend this meeting, we have, however, a technical intervention given by Professor Carmen Bushu regarding the curriculum in education and specific programs for astronomy. Carmen, you have the floor.
Hello, Your Excellencies. Hello, dear students. I'm here to talk you about the implementation of astronomy education programs in Romania. So, I'm here for me and for my colleague from the Ministry of Education, Ana Elisabeta Nochi, the Inspector for Mathematics and Astronomy. In education, astronomy can be implemented both in formal and non-formal education. So as for the formal education, there are two optional subjects that can be implemented so far and who was approved by the Minister of Education. First in 2022 for primary education, for primary schools, and the other one in this year in 2025 for secondary school education. So this subject can be implemented 1 hour per week in each primary school and each secondary school. In order to implement this subject, more than 250 teachers were trained in 10 training centers for teachers in the entire Romania. Another way to implement education is non-formal education, and we have here national competitions and international competitions, and also now we are implementing an Erasmus Plus project named Exoplanets for Education, and you have there the roll-up. As for non-formal education, we implement as non-formal education some sort of international programs in astronomy. So each year we have implemented the 100 hours of astronomy in October, the World Space Week, the Astronomy Day in School, the Global Science Opera, the Women and Girls in Astronomy, and CanSat Romania SF. As you can notice, we have here a map of astronomy education activities in Romania, and you notice that a lot of countries in Romania implemented such activities. As for the Astronomy Day in schools, for example, we have in the school year 2023-2024, 26 educational institutions from 16 countries in Romania who have implemented this program. For International Day of Women and Girls in Science, Astronomy, also, we noticed that 25 countries from Romania implemented this program, and we have here the map of the institutions where this program was implemented. Another example, the fifth show IAO workshop Romanian language conference on November 23 was also implemented in a lot of Romanian countries. As you know, our students are very interested in competitions, national and international competitions, and here we have the number of activities. For example, we have 44 presentations at international competitions, 54 national competitions. We have 78 national extracurricular projects who were not funded. Not all the programs are funded. Some of them are funded, some of them are not funded. And the results are here. Our students, as you can notice, have honorable results. So we have a lot of gold medals, silver medals, bronze medals, honorable mention, so a total of 73 gold, 119 silver medals, and 29 bronze medals. We present here the participation of our students at International Olympiad of Astronomy. also at the International Olympiad of Astronomy and Astrophysics for seniors and also for juniors, who was established by Romania in 2022. And also you can notice that a lot of students are awarded with gold, silver, or bronze medals. Now, I would like to tell you about our project, EXO for Edu, an Erasmus Plus project, who was implemented by 4 organizations from France, Romania, Portugal, and Albania. This project will be implemented during 36 months, and it aimed to disseminate the teachers from secondary and high schools, and also students from 12 to 18 years old. Through this project, teachers will be trained in 2 summer schools and also in national trainings. And students will participate at extracurricular activities in at least 4 schools in each participated country. So, thank you very much for your attention.
Thank you, Carmen. We cannot say astronomy without the presence of our enthusiastic amateurs and enthusiastic true astronomy, education through astronomy made by people who are, let's say, in their heart, the knowledge of the sky and the beautiful of the sky. I will invite now, because this talk will be given by 2 voices, I will invite now 2 representatives of amateurs who will speak about their activities, and also they will present you some numbers. Andrei Gosan from Romania, please, you have the floor. 8-10 minutes.
Good afternoon. My name is Andrei Gusan. I'm an amateur astronomer and the president of Astronomia NGO. I am grateful for the chance to speak in behalf on every Romanian astronomer and astronomy club. And I would like to thank you for the colleges that helped me create the presentations today. Today we want to present you the current state of amateur astronomy community from Romania. But first I would like to say a few words about our NGO. Astronomia itself was born in early 2000s around Romania's first national star party. Since then, our passion for the night sky have turned into a vibrant national movement. Last year, we formalized as an NGO, and today we have more than 7 active members across the entire country. We aim to promote and support and coordinate activities that contribute to the development of astronomy from a social, educational, cultural, touristic, and economic point of view. Today in Romania we have 20 official local amateur astronomy clubs with more than 360 active members. Among these, there are also dozens of unaffiliated astronomers and private personal home-built observatories. There are 11 public observatories and planetariums in Romania, and thanks to them, everyone in Romania is no more than 90 minutes away from a telescope. We aim to highlight that in the last decades, astronomy was almost absent from Romania's national curriculum, so local astronomy clubs and public observatories were nations' classroom under the stars, conducting non-formal education. Their role in sparking curiosity, guiding talent, and even delivering publishable research cannot be underestimated. And we want to thank you for their effort. Today, we practice ad hoc sidewalk astronomy sessions inside cities for sun, moon, and planets observations. We organize star parties, dark sky observation sessions, astrophotography marathons. We attend to science festivals and create custom educational events for school, museums, and city councils. Here we have a few images from across the country. In the last 12 months, our united effort across the local class from Romania, we delivered 150 public events to 28,000 direct participants. That's thousands of new telescoped first-time looks and countless of new wow moments. To turn our vision into reality, we believe that teamwork is essential. Romania partners with local clubs, NGOs, high schools, museums, and local institutions. By sharing mobile telescope volunteers, planning joint events, we work together, not in parallel, and bring closer the night sky to every community. On air and online, we reach far beyond the eyepiece. A weekly radio show, a TV slot, spontaneous live streams, plus Romanian astronomy groups are present. Astromania was founded to wave a unified national network. Shared telescope, joint training, a common events calendar, and coordinated research program will make us a reliable partner for professional scientists and international collaboration. We look for citizen science achievements. Romanian astronomers have co-discovered variable stars, asteroids, extragalactic supernovas. Some objects now carry Romanian names. Imagine what we can achieve when we act together. The Romanian astronomy is bright, so look up, join us, and let's reach for it together. Thank you.
Thank you, Andrei. The next speaker will be Valentin Grigore. Valentin made my day because he sent me a presentation with 180 slides. So he said that also he will do this in 6 minutes. I will bet that this is not possible. Valentin, you have the floor. We know each other since a long time, almost a millennium.
Thank you, Mr. Director. Thank you for your invitation. And now I want to speak only a little about our activity of 33 years. I am the president of the Romanian Society of Meteorology and Astronomy. Also, I am the national coordinator for the Astronomers Without Borders organization. Also, I am TV astronomy, as on the sky, 18 years ago. And now...
You have no slides.
Yes, I have no slides. Okay, thank you. Also, because I am very active in the dark sky protection, I am lightning specialist. I'm a member of the National Committee of Lightning. Also, I am in the editorial board of the Global Astronomy Sky App. Okay, I think that astronomy begins here, on the grass, because here we can find the universe. For the first step is here. Romanian Society for Meteorology and Astronomy was founded in 1993, the first national astronomical society after the Romanian anti-dictatorial revolution in 1989. And our concept is astronomy, culture, art, education, society. Also, we are a youth organization. In our long activity, we organize over 600 events. Over 100 are national level, 8 international, 2 world events. Our main activity is the National Camp of Astronomy, founded 33 years ago. And this was the modality to connect again people to the astronomy after the communication crash. Over 80,000 participants and over almost 1.5 million the people reach our activities. Also, we organized 18 overseas expeditions with more 400 participants, especially to visit the European Northern Observatory in Canary Islands, also to see the eclipses. Total solar eclipses, you can see here our expeditions. Also, we edited a national astronomic magazine, printed, and after that, I set up this TV show, Us on the Sky, Columna TV show, TV, we have reception national territory of Romania. Our partners in Romania, some ministries, you can see here Ministry of Youth, Education, Culture, Romanian Army for our camps, university schools, local authorities. Also, we have a good relation with the mass media, is very important. Astronomical Institute of Romanian Academy, National Astronomical Observatories, Romanian Space Agency, we will organize some events together. Astro Travels, Routine Tour, Astronomical Association and Clubs, Dumbrisa Youth Foundation, many others. International, we have cooperation with International Astronomical Union, International Meteor Organization, also we are member of Astronomers Without Borders, European Solar Observatory, International Sky Association, and other important institutions. Also, we participate in over 40 world astronomical events where we were invited to attend this event organized by these institutions. Also, my TV show, Us on the Sky, started in November 2008, like a project for the International Year of Astronomy, and the rating was very good, and this pilot project is now is alive now after so many years. So you can show my TV show. Also is live on internet, not only on TV. Also international participation in this TV show, you can see from other countries, our collaborators or professional astronomers, not only amateur astronomers, are visiting our studio to take part in our TV, also from United States, from NASA, and also we organize a Festival of Astronomy in 2019. We organized the International Festival of Astronomy in Târgoviște. You can see some guests from United States, from Australia, from Sorbonne University, from Paris, from NASA. Also our partner, forever partner, Dr. Mirel Volan from Romania. Yes, yes. Okay. Our activity is very complex because we have this combination between astronomy and culture aspects, astropoetry, and other connection with astronomy, astrophotography. Also, our partner, cosmonaut Dumitru Prunariu, attend sometimes and hope to have a game this year. Mike Simmons, the president of Astronomers Without Borders, with our cosmonaut Dumitru Prunariu, was came in Târgoviște in Romania for this festival. Also, we have a long cooperation with International Meteor Conference. We attend in 23 editions at this world event. And also, we organize 2 editions in Romania, in 2000, in Pucioasa, Romania, and 2011 in Sibiu. The former president of Romania, Klaus Iohannis, was the mayor of the Sibiu city when we organized this event. Also, for International Year for Astronomy, we were invited to attend the opening ceremony in UNESCO in Paris, in France, and have contribution for this great event. Also, we have received Hengli Commended Award for the largest single registered 100 hour of astronomy event in Târgoviște, and also we were the winner for the outstanding Galilean Nice event in Târgoviște. Also, International Astronomical Union sent us the recognized. Okay. Also, we are connected with the light pollution and protection of the dark sky, because it's very important for us to have the dark sky accessible coming years. We attend many international events, also co-organizer of the Starlight Beyond Light Pollution in La Palma, Canary Island. Alan, in Cluj-Napoca, Romania, International Year of Lights. Also Lights of the World in Romanian Parliament Palace. We present our concept about the necessity to protect our sky. Also, I attend International Astronomical Union General Assembly.
Okay, thank you so much, Valentin. Okay. It was exciting, but I know that you have a twin. The twin is Andrei Dorian Gheorghe. Andrei wrote a book right now, and I give the floor for 90 seconds just to have a present for Monica Rubio. Yeah, okay. Thank you.
Just must to end my presentation with our experience in Chile, because we were in Chile to see the total solar eclipse, and I want to present this experience because was a great opportunity to see the very dark sky from Chile, and want to return in this place because it's the paradise of astronomy in this special area.
Please. Thank you.
Thank you very much.
Mulțumesc. Doamnelor și domnilor, I'm Andrei Dorian Gheorghe from the Romanian Society for Meteors and Astronomy, and I greet you with a personal poetic astro-proverb. In the house of the universe say, it's mine, but talking to the stars, you must shine. In this respect, a teacher of mathematics, Ion Otescu, with the help of Romanian teachers, priests and peasants, wrote a book on Romanian beliefs about constellations, heavenly bodies and celestial phenomena, which he presented in 1907 right here at the Romanian Academy. In 2024, the British astronomer and mythologist Alistair Macbeth and me, with the support of the editor Dan George Uza from the Astromix publishing house, made an English version of Ion Otescu's book named Romanian Sky and Star Lore. Here is a book which I have the honor of giving to Mrs. Monica Rubio. Thank you.
Thank you, Doru. You overpassed the 90 seconds. So, the last, let's say, the last speaks of this day, but not the end of the meeting, because we have an informal part after that. It will be given by the Astronomical Institute of the Romanian Academy, and I will be here at the in front of the desk as a representative of my colleagues from the Scientific Council of the Astronomical Institute. So I will be short. I will not make you spending a lot of time, just in order to be sure that after the presentation, I will invite you to outside to take a picture, a group picture, and then to come and join us for an informal part, take a coffee and discuss in the hall just nearby. Okay. So, who are we? We are based in 3 locations inside the Astronomical Academy, Bucharest, Cluj-Napoca, and Timișoara. We are reporting all the activities for astronomy as an entity for the 3 different locations. We have also 2 observatories, namely one in Bertolo, and the other one, it doesn't work, never mind. And the other one in Feleacu. This is the station, the newest station, almost robotically, remote observing robotically, that was installed near Hațeg, in Hațeg County, in the county called General Bertolo. There is an IAU code. We have several. We overpass several steps in developing this facility. Why it doesn't work? Okay, it doesn't matter. And this is the other station in Feleacu, near Cluj-Napoca, on the Feleacu Hill, with telescopes. We are the Astronomical Institute own also an all-sky network of about 20 cameras, which are spread over the country in order to detect and find meteorites. We are belonging to a large European network called FRIPON, which start in 2014. I was in the core team of this network at that time, and I am still there in France. And then the network was successful, and this was enlarged over Europe. And as you can see, we have 2 countries which are highlighted there: Romania as the most eastern country in Europe, and Chile as the most western in the network. We are dealing with studies about artificial satellites. You know that space is a limited resources, and the topic of constellations of artificial satellites requires a lot of attention because of a problem from the observation, astronomical observation from the ground. We cannot. We admit that the technology is something which need to be accepted as astronomers, but also we need to find parades or we need to find tools for having also our observations from the ground. When I said observation, it is not only on visual or infrared, it is also on radio spectrum, so we need to be careful. We are part of the I1 UN COPUOS network, so we are there for observing, and we are successful. We are very, very active in this network of the United Nations. And also, we are looking also for problematics related to low Earth orbit satellites and also re-entries, because we have, as far as the density of the objects increases, we are counting for we estimate that in 2030 we will have more than 500,000 of objects on low Earth orbit. It will be very, very problematic for us. We have a huge experience on dynamics of solar atmosphere and heliosphere, and here you have a lot of topics related to the sun, and these topics the Institute is involved inside the European and also international networks. We have an experience as observers and also modelers in looking to the sky for solar system objects such as asteroids. Here you have a presence of astronomers into a large program developed by the ESO, European Southern Observatory. You can see here the very large telescope in Paranal, where we finished the large program in 2020. We have also some experiences related to galaxies, star formation, and we are working with this, a small team who is involved in such kind of problematics related to the universe and cosmology. Also, we are present in the media and also in the social life by hosting visits of scholars, and also by organizing activities inside the institute via networks or in the frame of activities proposed by International Astronomical Union, European Astronomical Society, and so on. You have here some numbers related to our institute, 24 astronomers, so a small community. We would like to enlarge this community, 2 PhD supervisors, 6 PhD theses in 2025. On average, we are organizing and we are part of the scientific organization committee for about 3 international meetings. We are organizing also seminars inside the institute. We are the owner of the astronomical journal, Romanian Astronomical Journal, and also on average we are publishing either in prime authors or first author or co-authorship of about 25 ISI articles, and the majority in the red zone, I mean the highest scored journals. Again, a few numbers. We have 13 projects underway, 6 international, 7 national. We are contributors of European space surveillance and tracking. We are the owner of a unique architectural and historical patrimony, a huge task for such a small institute, so we need to have also to pay attention to such kind of heritage. We are a contributor to several networks, partnership with academic, economic, and social entities, and we have unique competencies related to ephemeridis, astronomical observation, dynamical and physical modeling of celestial bodies. Thank you very much. Okay. I will sum up this formal part of our meeting. I invite you outside to take a picture of this forum. I am very, very happy that you are here. and very, very proud that the mobilization is here and my colleagues are here. I have no words. I sincerely declare that this meeting was a successful story. Thank you. Let's go.